Hello everyone, welcome to today's class. So for today, we'll be looking at word problems involving fractions. Remember, we are still in fractions, so we'll be looking at the word problem part of it. And under the word problem, we'll be taking it in three phases. The first one will be finding remaining fractions. Finding remaining fractions. Now, the idea behind word problems involving fractions is that you must have an understanding of what we mean by word problem, and that involves converting the long statement you are seeing into mathematics, representing the long stories you are seeing and bringing it into mathematics. Now, why this is very important is because this is the first topic we are having word problems, and other we will have so many topics after this that involves word problems. So this is where the understanding needs to come first so that we can apply it to as many word problems we are going to see. Understanding the word problems in fractions will help will do us so much good in understanding other word problems that are coming. Okay, so the first one, like I said, will be finding remaining fractions. Finding remaining fractions. Before I go deep into the example, now when we talk about finding remaining fractions, what we are looking at is that we are trying to see if we have a total fraction and then a part of that fraction is given out, what fraction is left? We have a fraction, or we have a total fraction, and then a particular part of that fraction is given out. So what fraction will be left? Okay, and then also you must understand that fraction is also a system of number. Fraction is a system of is a different number system on its own. So while you may try to say something in the normal number form, another person may decide to say that thing in the fraction form. That's the same thing we have even in percentage, which we'll discuss later. Something like percentage is still a system of representing number. So because most times some students mix up the fraction system and the number system, they merge everything together. But we need to differentiate. Now, in a school, let's look at example one. In a school, 5/8 of the students are girls. What fraction of the students are boys? In a school, 5/8 of the students are girls. What fraction of the students are boys? Now, one of the things you need to do in word problems is that you must make sure that you write out what is being given. Make sure you carefully list out what is being given from the statement. Write out what is being given. Okay, in a school, 5/8 of the students. So we've seen 5/8 here. We need to know what this 5/8 stands for. 5/8 of the students are girls. 5/8 of the total students are girls. Now, this is fraction. This is fraction. 5/8 of the students are girls. So you will note that from that question, what we have there is that the of girls fraction of girls equal to what? Equal to 5/8. Is equal to 5/8. Now, what are we asked to find? What fraction of the students are boys? So the next question is fraction of boys. That's the next thing. Fraction of boys is what we are looking for. So we use a question mark. Now look at this. Before I come back here, let me explain something here, please. I need your attention here. Now, let's say you have total students This one now I'm trying to explain in numbers. You have total students, maybe you have 200 students, and then you have number of maybe boys. You have boys to be 96. How do you get the number of girls? How do you get number of girls? Number of girls will give us what? That should be the total student minus the number of boys. And that will give us 104, which is what we are looking for. So that is, we are dealing with the normal number system. That's finding the remaining number. That's the same principle that comes here. Fraction of girls has been given. You are to find the fraction of boys. But there's something that we need to get the fraction of boys. What we need is total fraction. Total fraction. Now, when you are having fraction, when you are having fraction, if something is being shared into fraction, the total fraction is always equal to 1. Please take note. Our total fraction is always equal to 1. Total fraction is always equal to 1. So you will not be given total fraction in the question, but please put it in your mind. Just like when we move to percentage, if you take it to a percentage system, total percentage is always equal to 100. So total fraction is always equal to what? 1. So we have our total fraction here, which is 1. And then we have fraction of girls being 5 over 8. So from this total fraction, which is 1, we've removed fraction of girls, which is 5 over 8. So how do we now get the fraction of boys? So fraction of boys will be equal to total fraction. Take note. Please don't think that 5 over 8 is bigger than 1. No. Do follow the principle. Total fraction, which is equal to what? 1 minus the fraction of girls, which is equals to what? 5 over 8. So of course, this one will be equals to 1 over 1. And if we find our LCM being 8, that will give us 1 into 8, 8. 8 times 1, 8. Minus 8 into 8, 1. 1 times 5, 5. And that will give us what? That will give us 3 all over 8. So this is the fraction of boys. So fraction of boys is equal to 3 over 8. I repeat, your total fraction is always equal to 1. You will not be given that in your question. But note that the total fraction is always equal to 1. Okay, so let's move to number 2. 6 over 17 of the members in a church are women. 4 over 17 represent men. What is the fraction of children in the church? Okay, so let's see the solution. So we have fraction of what? Fraction of women is equal to 6 over 17, and then we have fraction of men, that would be what? 4 over 17. And then what are we to find? We are to find fraction of children. That would be question mark. So what do we need there? We just need to know that our total fraction is equal to what? 1. Always equal to 1. So what do we do? How do we get our fraction of children? So the fraction of children. Now, this is just a simple logic. Let's say we have 100 suites in total. This is total. And then maybe we share 25 suites to men. Then we share 35 suites to women. And then we are asked to find the for children. We are now the children are the children will now get what is left. So how do we get what is left? How do we do it? I believe that will give us the total sweet minus the sweet given to men minus the sweet given to women, and that will give us what will be left. So the same thing now, we are now in the fraction system. We are now in the fraction system. So in fraction, what do we do? The same principle, your total fraction minus the fraction you've given for women and minus the fraction you've given to men. So that will give us 1 minus 6 over 17 minus 4 all over 17. So we get our LCM. Of course, this is 1 all over 1. So our 17 will be here. So 1 into 17, 17 times 1, 17 minus 6 minus 4. And this will give us 7 all over 17. So this is the fraction for children. That is the fraction for children. Okay, so please, I believe you understand that fraction is now coming in as a different number system from the normal whole numbers. So if you have a total fraction and then you've given out some fractions, just do as if you are doing normal numbers, but you are in fraction. And make sure if something is fraction and you want to represent it, just like I wrote here, you see, I took time to say this is fraction of women. I didn't say number of women because this thing here is fraction. So it must come as fraction of women. If it is number, you will say number of women. If we just write women equals to this, that women will assume that it is number. So if it is fraction, you must say fraction of women. If it is number, you say number of women so that it will have this beauty. The beauty of word problems is that you are able to interpret the word problems carefully into mathematics. That's what makes word problems beautiful. Okay, so please carefully go through it. You have examples here. Follow the terms, use the terms you are seeing. Now, this one has boys and girls. Number two has male and female. Number three has boys and girls. Number four has students that passed and students that failed. And then number six has bad oranges and good oranges. And then number seven has to do with sweet shared to first child, second child, and the third child. Please carefully follow the terms the way they are. Thank you very much for watching this video. Please do well to like, subscribe, and share. And then join us in the next part of the word problem. Thank you very much.